telling you X is discrete and Y is discrete. Here, Y has 3 levels, 0, 1, 2, and X has 6 levels. Take a look at that. Now, the very first question asks, what is the probability of X equal to Y? Okay, you want to identify where X and Y are the same. Okay, where X and Y are the same is where you're going to have 0, 0, 1, 1, 2, 2. I don't know, do you understand that? Can we have a 3, 3 on this table? No. So it's going to end up into 2 because the level of Y is not up to the level of X. Now, if I want to solve this question now, okay, that was why here. Okay, is there anyone who have a trouble time understanding this? What I'm adding, 0, 0, 1, 1, 2, 2. The last one is going to be 2, 2. It's not going to get to 3, 3 because the state space of Y. Now, all what I'm just going to be looking for, the 0.025 is actually going to be the probability associated. Take a look at this. When I get 0, 0 here, this is the corresponding probability. All what I just need to do is to bring out the corresponding probability. Oh, there's another one for 1, 1. What about the one for 2, 2? I think that guy, okay, and that was why you're going to add them up. That give us that. We don't. Now we're going to go into another one. Oh my God. What do we want to do now? Even though, if you take a look at what we have, the question said, find the marginal distribution of X and Y. If I want to find the marginal distribution of X and Y, if I were you, okay, if you want to do the marginal distribution for S, 4 of us bring this guy out. Okay, why do I have 0 to 5? Because when you take a look at this guy here, X has a state space of 0 to 5. Okay, now if S has a state space of 0 to 5, okay, now it means I'm actually going to have 6 probability numbers. What am I going to do? I'm actually going to sum. Like for instance, when S equal to 0, I'm summing all of these across Y. Okay, summing of that across Y for 0, that gives you 0.05 here. Any question? You did that for 1, all of that. Is there any question on how I set this guy up? Do you have any questions setting up that guy? Okay, let me tell you this. If you're not able to set up this guy, you may not be able to answer the next question. Because the next question may ask, find the mean of that. You know that with this guy now, I can find the mean. You remember what we've done before. This is just going to be the mean of X. Because the moment I got this guy out, just need to be multiplying that, add them up. That will give me the mean of S. Automatically. Give me the mean of S. I'm also going to do the same to the marginal for Y. Oh my God. The Y 0, 1, 2. Okay, getting the 0.5. What did I do? Getting the 0.5. Oh my God. For Y, I'm actually, since I got 3 levels for Y, okay, for Y equal to 0, I'm going to sum all of that. For Y equal to 1, I'm going to sum all of that. For Y equal to 2, I'm going to sum all of that. What am I summing that? I'm summing that over the range of S. Automatically, you see what I got right here. Okay, so this guy now give me the marginal. That's a marginal distribution for Y. And if they ask you to find the mean of Y, that would be super cool. All what you just need to do is just to multiply the values of Y with the corresponding probability. Now, this is where I'm going now. We want to come back now, take a look at the next question now. Okay, the next question talk about, please take a look at this. It says, suppose a bus occupies 3 vehicle spaces. A bus. Of course, a bus is bigger than a vehicle, right? So a bus occupies 3 vehicle spaces and a car occupies just 1. What is the mean number of vehicle spaces occupied during a signal cycle? Let me tell you this. Based on what they say, you are going to be the one that will interpret that as that. X plus 3y. You'll be the one that will do this job. A question can just describe a scenario like that. Okay? But you have to first of all define. Look at, can you go up here? What does X represent? X represent the numbers of cars, and Y represent the numbers of buses. Then we're going to have a function of X and Y that we also going to call a random variable. Find it in me now. We want to find the mean of this guy. This guy here is not a probability function. This guy here is a random variable that is a function of X and Y. Now, if I now want to find that, okay, oh my God, you're going to see what I'm going to do right now. Look at that. Okay, I want to find the mean of this random variable, x plus 3y. It's going to be summation. That random variable, the joint probability. That's what you have here. Super cool, right? Is there any question on this before moving forward? Is there any question? Do not hide your feelings. Is there any question? You good, right? Okay, now you're going to see what I'm going to be doing now. Okay, I'm going to go back to the table. Take a look at this guy. You know, I'm going to start from 0, 0. If I go to the table, look at the table. I'm going to start from. Do you know the number of pairwise combination that we're going to have? 6 multiplied by 3. That will be 18 of them. I'm going to have 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, until I get to 5, 2. Okay? Please pay attention. And which is what I'm doing here. Take a look at this guy. It's a lot. When you see ... this is a lot. Okay? You see that? I'm plugging in when x is 0, y is 0 into the function. Then, for what is the probability associated with 0, 0? Okay, I'm going to go to the table. It's 0.025. Okay, I'll do that all the way. Oh my God. That very mean give us 4.90. Is there anyone who need clarification on how we go 4.90? Is there anyone? Okay, if you're super cool. This is not the only way we can go about that. Do you know that I can go alternatively if I want to find this guy based on what you've done before? This guy multiplying is going to be expected value of x plus 3 expected value of y. Look at that. Do you know that from the marginal table that you created for x and y the other time, you can find the mean of x separately, you can find the mean of y separately. All you just need to do, plug them in, they multiply by 3, you're going to get the same result as that. Why can't you try that? Also going to give you the same result. Okay, you know what? We don't normally have issue when it comes to discrete, but the issue normally comes when it comes to continuous. And I really wanted to pay attention now on how we're going to do this. Now, we want to talk about bivariate continuous distribution. You know, S is continuous, Y is continuous. We look at the probability axioms. Again, f of xy has to be non-negative. And of course, integrating that, f of xy, there's the y have to be equal to 1. Okay, this continues to go all the way, okay, to 3-dimensional and so on like that. Now, if I'm seeking to get the probability of x and y, I must be ready to perform an antiderivative on f of xy, okay, about the x and y. And of course, I also show you on the board the other time, you know, if I want to, this is getting the f of s, okay, marginal f of s, and this getting marginal f of y, okay. But you know where I'm going now? I've shown you how to find the mean of a function, of a combination of x and y for discrete. How do we do that for continuous? Please, I need you to pay attention now. Okay, you know, we got this is a random variable, but this time around the h of xy is continuous, not discrete, and we are seeking here to get the mean. You see the mean of that, I want to get the mean of that. Getting the mean of that, you have to put into consideration the numbers of variables involved. Okay, if the combination involves 2 variables, you're going to have 2 integrals. If it is three variables, you're going to have three integrals. If it is one variable, it's going to be one integral. And you can see the reason why here. And do you understand how I interpret that? That is a way to figure out the mean of a function of random variable, and that is x, function of random variable x and y. They are both discrete. And I'm going to have integral h s of y. Then this is a joint probability function for that. Then there's the y. Okay, please, I needed to pay attention, and don't forget the one we've done before. If you want to look at the mean of x separately, of course, that's how you do, right? Mean of x separately, right? And you want to get the mean of y separately. That's what you do, right? Okay. Now, I'm going to go into an example now. Please, I need you to pay an attention. Okay. Now, take a look at this. Let x and y be jointly distributed as that. Maybe x here is the proportion of time the working facility is used in a bank by customers, and y is the proportion of time the drive-in facility is used. Now what the bank official really want to understand here. What is the probability that 25% of the time the driving facility will be used, while 25% of the time the working facility is used? This is a maximum that the working facility is going to be used within 0 to 25%. And the driving facility also going to be in use, within 25%. That's what we want to figure out now. So here now, we want to find simultaneously the probability of x and y equal to a realized value. It doesn't matter. This can be what you need to do. You see that? If I'm starting with the s, you can see the first integral that appear close to the s. This is going to be a sequential integration. I'm going to do this guy first. Do you see that? Then after I'm done with that, then I'm going to go for the second one. And at the end of the day, I'm going to get this result. Is there any question on this? You just need to revisit your knowledge of antiderivative. Okay, now I'm going to move right now. That's how to get it joined. Oh my God, this is going to be complicated. Now take a look at this. You have a function that is not completely specified. Why is not completely specified? Because of k. K is a constant. That k needs to be determined. And not only that, s high lie between 0 and 1. When they say si lie between 0 and 1, mean x1 lie between 0 and 1, x2 lie between 0 and 1, x3, because here this is a function of x1, x2, x3. Does that make sense? And we have another restriction. Take a look at that. This look like the chemical example that I walked you through the other time. X1 plus x2 plus x3 must be less or equal to 1. Okay, now I need you to pay attention. The very first question said, compute the joint marginal density function of x1 and x3 alone. Let me tell you this. The full one has s1, s2, s3. If I'm interested in just x1 and s3, then it means I'm actually going to marginalize. I'm going to integrate